Sometimes with Lewis structures, you can draw multiple different Lewis structures for a single molecule. So, for example, if we were drawing the Lewis structure for carbon dioxide or CO2, you might come up with possibilities like this, and this, and this. So, how do you know which one is the actual Lewis structure? We can use something called formal charge to figure out which one is the actual Lewis structure. So let's get right into it. So, what is formal charge? Well, formal charge is really just almost like a way of keeping tabs on the number of electrons of each atom within a Lewis structure. So, it can be calculated, or it's formally defined as taking for the atom the number of valence electrons and then subtracting half of the number of bonding electrons. Because we're talking about covalent compounds, taking half of that makes sense because half of the electrons are coming from that atom and half of the electrons are coming from another atom. And then finally, we're also subtracting the number of non-bonding electrons. So those ones paired, we're subtracting those as well. So that means if there are a number of possible Lewis structures, the most reasonable one is going to have a couple of characteristics. First, if we take the difference in formal charge from the one with the maximum value minus the one that has the minimum value, and look at all of the different possibilities, the one that's closest to 0 is going to be the most reasonable structure. And also, the one that has the negative charges located on the most electronegative atoms is also going to be the most reasonable structure. So we can look for these two characteristics after we've calculated formal charge to see which of the possible structures we have is the most reasonable one. So let's take a look at an example. If we have BF3 is one of these weird Lewis structures. So we could have something like this, BF, F, and F. And then we could have electron pairs around the fluorines. So that's one possible Lewis structure. The other possibility is that one of these is double bonded. And so that looks like it's satisfying the octet rule, whereas the other structure is not. We only have 6 electrons around that boron in the center, or that central atom. So which out of these two is the possibility? Well, let's go through and let's do the formal charge for each of these atoms on this first structure. So we're going to look at first the formal charge of the boron. So doing that calculation, the number of valence electrons is 3. And then we're going to subtract half of the number of bonding electrons. So there are 6 electrons bonding there. And then minus the number of non-bonding pairs, which in this case there's 0. So when we do formal charge on that boron atom, that would be 0. For the fluorines, since they're all the same, they all have 3 pairs of non-bonding electrons and 1 bond to the boron, we can just do one calculation for that. So valence electrons is 7. We'll do half of the bonding electrons, which is 2. And then we'll subtract the number of non-bonding, so 6. So 7 minus 1 minus 6, that also gives a formal charge of 0. So all of these atoms within this structure have a formal charge of 0. Now, if we go over and do the same thing with the other structure, let's go formal charge of boron. Again, 3 valence electrons. We'll do a half. And now at this point, there are 8 bonding electrons. And there's still no non-bonding pairs. So 3 minus 4, this gives a formal charge of -1. And then if we take, let's do different colors here. So these first 2 fluorines, they're going to have the same formal charge as what we calculated in the other structure. So they're going to have a formal charge of 0. But this one here, if we do the formal charge of that fluorine, then that is going to be 7 minus 1/2 times 4 electrons in this case, minus 4 for our non-bonding electrons. So 7 minus 2 minus 4 gives us a formal charge of 1. Now, if we did the change in formal charge for both the max minus min, for the first structure, it's 0. And then for the second structure, we have 1 as our max minus our min gives us 2. So kind of taking a look at both of those, the first structure is the preferred structure because the change in formal charge is 0. And we also have, the negative charges are not on the fluorines itself, but at least they're 0 in this case too. So going back to that first structure for carbon dioxide, we're not going to calculate them all, but I just have the formal charges here showing for all of the different structures. So this first structure is the preferred one because the delta Fc is 0. And the other ones, the delta Fc would be 2, and then in this case, it would be 4. So this first structure is the preferred structure. That's it for them for this video. I'll see you in the next one.